Hello everyone, here we are going to discuss today it is about limitation of dimensional analysis. So already we discussed that is the application where we can use this dimensional analysis. What the thing gives the restriction to this? So that is the today's topic. So for this very first we are going to learn that in case of this dimensional analysis that there is whenever any dimensional constant involved, so that physical relation cannot be determined. Okay, so as example we said over there that and this force between the two charges, so it is given by product of the charge upon my square of the distance. So there we use this constant. Okay, so this constant, it doesn't mean that it was dimensionless constant. Okay, so it is also having the dimension. Okay, but this formula cannot be determined with the help of this dimensional analysis, because according to it that constant is what, dimensionless. Similarly over there, that if we say it is of about gravitational force. Gravitational force is what, it is that mass attraction. So it is product of the mass upon my square of the distance. So there we used g. So this g is also constant, gravitational constant, but it is having its dimension as well. So therefore it is what, a dimensional constant. What, according to this dimensional analysis, this g will become a constant which do not have any dimension. So therefore, even though this relation cannot be determined. Okay, therefore next that which puts the restriction on the uses of this dimensional analysis. Now the second point, which is regarding to the limitation, it is dimensionally correct physical relation may not be true. Okay, so as it is said student over here that which we have already determined as equal to ut plus of half at square. Is this dimensionally correct? Okay, so we are getting that left hand dimension is equal to right hand dimension. This is dimensionally correct. What if you will write over there as equal to ut plus of 80 square? Okay, so this will be dimensionally correct. It is dimensionally correct. If you will write over here that s is equal to ut minus of half 80 square. So even though this is dimensionally correct. Okay, so over there that those physical relation which is dimensionally correct, it is not that they are true. Okay, so here it is only the true case, but these are not the true case. These are not any physical relation. Okay, so therefore this is that over here the problem of this dimensional analysis, that we can not sure about whether the given relation is true or not. And the third limitation which is over here, that it is going to fail to derive the relations. So whenever there is the plus or minus in the equation, so that type of the relation it fail to derive. Okay, so therefore here if you will look that ut plus is between the two factors over here, so therefore it is failed to derive such a relation. Similarly over here that it is that v square minus of u square is equal to double of as. Okay, so such type of relation which is related with each other by plus or minus, so such a relation that cannot be derived with the help of this dimensional analysis. Now the fourth restriction which is on that dimensional analysis, as we did over there that dimensional analysis, so there we have compared the powers of m, l and d, homogeneity principle. Okay, so what we did over there, we compared the power of mass, length and time. Okay, so therefore it is going to that derive only those relation which involve only these three physical that quantities, which involve these three and that factors. Okay, but if there are more than these three, so that cannot be derived with the help of this dimensional analysis. So that's why we are going to say over here that It is used only for the relation involving only three independent factors. But if there is more than three, so that you can't use this dimensional analysis for this. And similarly, one more which we can use in this case, that if there is any trigonometric function, so trigonometric functions such as sine, cos, which we are having, or either that logarithmic function. So in that logarithmic function, there is no information regarding to this one, and that of exponential function. So such a function, that this information not given by this that of dimensional analysis. Okay, so that's that is the restriction which is on the uses of this dimensional analysis. So that's all from my today's video. Thank you for watching.